Hi everyone, we have a video here on special right triangles. The special right triangles are really only special because they have some convenient ratios between the sides that are easy to remember. Any right triangle will have ratios between the lengths of those sides. They're just not as nice to remember as these two. The first one is the 45-45-90. The isosceles right triangle. We know that that third angle is 45 because 45 and 90 is 135. To get to 180, we have another 45, certainly. And if those two angles are congruent, the two sides need to be congruent, making it isosceles. The values here are these: L for the two congruent sides and L root 2. No, I did not suddenly confuse letters and numbers. These are formulas and properties. So anytime you get an isosceles right triangle, it will obey this relationship. Two sides are equal and the hypotenuse is equal to that length times the square root of 2. So you can use that to find missing measures. Okay, the other one, and you can think of whatever you want that L stands for: leg, length, whatever, as long as you remember that relationship. The other one is 30, 60, 90. Again, we know it's 30 because 60 and 90 is 150. To get to 180, we need another 30. The variable here is s. You can, again, decide for yourself why that you want it to be s. I think of it as the shortest or smallest value. And again, I use cursive just to make sure that we're not confusing. Like s could look like a 5 or L could look like a 1 if we used, regular printing letters. So you can see there that s across from the 30 has to be the shortest side, right? Because 30 is the smallest angle. We know that from our lesson on triangle inequality. And again, you can see that they go up, right? 60 is the middle angle. S times root 3, which is between 1 and 2, is going to be bigger than S, but it's going to be smaller than that number times 2. And again, you can use this to find missing measures. So let's do a couple examples. Here's a 45-45-90. I want the values of X and Y. So if we have this, again, we know that this angle and this angle are congruent, meaning that those two sides are congruent, and I can say y equals 9. They didn't give me a very large answer line here. For x, so we know that these two are L, those two are equal, and the hypotenuse is equal to the length times the square root of 2. So I'm going to say that x equals 9, which is L, times the square root of 2, and I'm going to stop there. Unless I'm asked to round, in which case I would do that on the calculator, okay? So that's all you need to do here. 9y is equal to 9, because those two sides are congruent. Take that 9, multiply by root 2. There's your hypotenuse. 4 is a little bit more complicated because we're going to have to do some radical multiplication in the next step. So again, we know these two angles are congruent, meaning these two sides are congruent, meaning those two are L. That hypotenuse is still L root 2. So V is equal to 2 root 2 because those two are congruent. U is equal to L, which is 2 root 2 times root 2. I don't get to skip that root 2 that I know has to be multiplied for the hypotenuse because it's already there. No, I have to do it again. And as you may remember, when you multiply radicals, you can multiply numbers underneath radicals with other numbers underneath radicals, but not with numbers outside. So I have 2 times the square root of 4 because I'm going to multiply the two 2's underneath the radical. And the square root of 4 is 2, so I would do 2 times 2, which is 4. And the reason this is a little bit harder is because we have to do division by a radical before we do anything else. So we're actually going to look at one like that right now. So here again we have L, and then we have L root 2. And the nice thing here is because when we are done with the problem, we know that X equals Y equals L. So we're just, as soon as we find out what L is, we have our answer. But the problem is there's something in the way of that. So we have L root 2 equals 5. And the problem here is because, well, it's a little bit complicated, right? We have to divide by root 2. That's not complicated by itself. But if you've been told that you can't use decimals, then that's when it gets complicated, because you should remember the rule. We don't like to have radicals in the denominator. So what we have to do is we have to take and rationalize. And if you don't remember how to rationalize, go and check the channel. There is a video for that. So I'm going to do root 2 over root 2. I'm going to multiply. That's going to get me 5 root 2 over 2 for L. And again, that's because 5 times root 2 remains the same, but root 2 times itself cancels the radical. So my answer for L, which is x and y, is 5 root 2 over 2. Now, again, you have this. This is the hardest it's going to get for 45, 45, 90. But again, you have those formulas. You have to remember them. You have to use them. Okay, so again, my tip is, as soon as you see 45, 45, 90, label the two legs as L and the hypotenuse as L root 2, and then go from there. All right. The other one, 30, 60, 90, I'm going to start the same way. I have the same suggestion. So S, the hypotenuse is 2S. And then the across from 60, the middle side is S times the square root of 3. So S times the square root of 3 equals 5 root 3 over 2. I have to divide both sides by root 3 here because I need to know what S is. Don't be intimidated by that complex fraction because there's a root 3 in the numerator already, and so we can just cancel those together. So 5 over 2 is S. You can also have 2.5 if you prefer decimals. So S is also V, right? Because that's opposite the 30. So V, this side, is just 5 over 2. And U is 2S, which is 2 times 5 over 2. So we cancel that out, and we're just left with 5 for the hypotenuse. And again, 5 times the square root of 3 over 2 is bigger than 5 halves, but smaller than 5. All right, so everything's how it should be. Okay. Last one. So S is this complicated thing here. We would know this is the 60, meaning N is S root 3 and M is 2S. So we would say that I'm going to do M first because that's going to be easy. So M equals 2S, which is 2 times 7 root 3 over 3. And I just multiply 2 times 7, which is 14, and the 3 and the radical 3 stay the same because there's nothing to reduce here. And again, numbers outside the radical can only multiply with numbers outside the radical, so that 2 only gets multiplied by the 7. N, I'm going to do N is equal to S root 3 equals 7 root 3 over 3 times root 3. Again, same idea as before. Numbers under radicals can only multiply with other numbers under radicals. So that's going to be 7 times the square root of 9 over 3. The square root of 9 is 3 over 3. Cancel. So I have 7 for S root 3. So one thing that you should remember, if what you're given doesn't, the one value they tell you has a radical in it, at least one of your answers will be an integer. If what they give you has an integer in it, at least one of your answers will have a radical. All right, so thanks for watching this video on the special right triangles, and make sure, like I said, if you are not sure about this whole rationalizing thing, check out the video on that.